Hello and welcome to Excellent Link Academy. For this class, we'll try to consider another concept under Binomial theorem called the general term of binomial expansion. Last class, we look at how to evaluate problems whenever you have a negative index or fractional index using the concept of binomial theorem. For this class, let's look at the idea behind the general term of binomial theorem. Under this concept, there are two key important things we'll be looking for here. The first important thing there is called number one there is called the how to, or perhaps look for two things there, how to find, or perhaps let's say finding the nth term of an expansion, and the second one there is simply finding the coefficient of term and constant term. Finding the coefficient of terms and constant term. All right, when it comes to the study of general term of binomial theorem, there are two key important things we finding there. One, finding the nth term of the expansion. Or number two, be finding the coefficient of term in an expansion. Right, so how do we go about these two concepts? These two concepts work with the same formula, which I'll be giving you now. So when I thought to find the nth term of an expansion, or I thought to find the coefficient of term in an expansion, you use the same formula. So the formula goes below. The formula is given by TR plus 1 equal to A to power equal to is equal to n combination r dot a to power n minus r dot b to power r. So note that when it comes to calculating or perhaps solving problems under finding the nth term of an expansion or coefficient of term in an expansion, we use this formula. So t is number of term, so r plus 1 equal to n combination r dot means times a to power n minus r dot b to power r. So let's now see how you can solve problems with these two concepts. Let's start the first one there, number one. Let's start with number one. For number one there, we are taught to what? Find the nth term of an expansion. Let's take for example to further explain this number one concept, right? So let's take number example one to explain this. Example says that find the fifth term. Find the fifth term in the expansion of x squared per se plus 3y all to power 8. All right, let's get this done, please. Now listen up. For this question here, it becomes a condition under what? The first one, not the second one, because here you're not hearing the word coefficient here. So I'm going with this. because I'm saying that find the fifth term. So to find the nth term, here now the n here is become fifth. The fifth term of what? Of the expression of this. So now here's the meaning, please. Here's the basic meaning. If I pick out this question now, I'm having what's it called? S squared plus 3y all to power 8. If I expand this using Pascal's triangle, right, I'll have the answer very long, right? But the task now is that for this one, they say that find the fifth term. It means that after expanding this thing, you know it will be long, right? We know that if I expand this one now, I'll be having 9 values. 9 values, right? If I count the first one, 1, 2, 3, 4, 5. The one that will fall at that position 5 is my fifth term, right? Which I'm looking for. That's the concept. Now we said to find the fifth term is quite simple. I apply the same formula. So I will recall that we said t to power r plus 1 is equal to what? N combination r dot a to power n minus r dot b to power r. What's r? What's n? What's a? What's b? Let's get it done, please. So note that n is equal to the power, right? That's 8. I've gotten n. What's your r? R is the term given. I'm giving what the fifth term, Abi. Find the fifth term. So I'm giving the fifth. So R is 5. Now listen up. For your R, always minus 1 from it. So since I'm giving fifth term, I have to what? Take a 1 from it. That becomes R now is what? Is just 4. Next up, what's your A? What's your B? From here now, A is equal to the first term here is what? X squared. What's your B? B is what? The second term here, 3y. So observe, get your N, R, A, and B. So note that your N is what? The power here. Your R is given as fifth term, so which is 5 here. Always minus 1 from it. That's the concept. So minus 1, I have 4. R is 4. What's your A? The first term, x squared. What's your B? 3y, as in this case here. All right, let's get it done, please. So solution. So I'll have that the fifth term, what's R? TR, R is 4 plus this one is equal to what's N? 8 combination. What's your R? That's 4 dot what's your A? That's x squared into n minus r. That's 8 minus 4. 8 minus 4 dot what's your B? That's 3y all to power what's r? That's 4. From here, that's this is the fifth term. The fifth term of the expression of this we give x combination 4. If I punch my calculator, if I have 8 shift combination 4, I'll have 70. This gives 70 dot x to power all squared. Abi 8 minus 4 is 4 dot what? This becomes 3 to power 4 y to power 4 from your indices. This one comes there, this one comes there, indices. What I get here, I'll have the fifth term of that expansion will be equal to 70 dot x to power 8 dot what? 3 to the power 4. 3 to the power 4 is what? 81. 81, right? Then what? Y to power 4. Combine this together, so it means that the fifth term of this expansion, t to power 5, will be equal to 70 times 181. I'll have 70 times 81 there. I'll have 5670 then x to power 8 y to power 4, x to power 8 y to power 4. This becomes the fifth term of this expansion. This becomes how to solve this particular problem. So note that when it comes to finding the nth term of an expansion, you will always be given r, right? You will always be given r. That's the concept. Let's do the second one called find the coefficient of term in an expansion. Right? Let's do the second one, please. Number 2 there. Finding the coefficient of term in terms and constant what the term. All right. For this concept now, the task is simple for this one. The task is similar to this one, but the idea is changes, right? So we know that coefficient means number in front of something. So if I think that I find the coefficient of x to the power 8 to the power 4, the value is what? 45670. This is the coefficient. This is the real value I want. So now when you're given a question under this one, now how do you do it? Let's take a particular problem under this and we are off. Example says that, let's take example 1 there. Under this example, right, it's going to says that find the coefficient of x to the power 7 in the expansion of I have 2x squared plus 5x all to the power 5. So if there's no how, if I expand this thing, normally I'll have 6 variable, right? 6 values, right? 6 term, like a term adding each other 6. I'll have expand this one, but there's a term that will have x to the power 7 as its variable. So what will be the number in front of it that we're looking for, right? So let's do this, please. How do you get this done? We said the task is simple. We are still applying the same formula, right? So recall at this point now, I'll recall that we said tr plus 1 equal to n combination r dot a to the power n minus r dot b to the power r. So how this get is done? It becomes, listen up, let's get n, r, a, and b. We said to get your n is the power, yeah? So my n equal to 5, no problem. What's your r? Now listen up, unlike the first example, r is given straightforward, that's 5, the fifth term, that's your r, right? But in this case now, r is not given. I'm just given what? x to the power 7. So r is not given for now. So our r is not yet given, so r is unknown yet. So let's get, what's your a? The first term, that's 2x squared. 2x squared, that's your a. What's your b? Second term, that's 5x. I'll plug in these ones that are given now there inside the formulas and let's see what we get. Plug in everything there, also what we get. If I plug in those values there, I'll have t, what's your r? Unknown, r plus 1 equal to, what's your n? 5 combination r dot, which is times, what's your a? That's 2x squared all to the power n minus r. What's your n? That's 5 minus r dot what's your b? 5x all to the power what? R. What's your r? Is unknown. From here I'll have that t r plus 1 equal to 5 combination r dot, this becomes idea of indices, 2 to the power 5 minus r dot x to the power 2 into 5 minus r. Apply indices. This one affect this, so I have this dot what? 5 to the power r dot x to the power r. Indices. So I'm applying this r will come here, r will come here. So I'm having this. From here I'll have t to the power r plus 1 equal to, I'm trying to get r, that's the concept now. So 5 combination r dot, from here if I apply the idea of what's it called, the idea of indices, what do I get? Perhaps let me just proceed. 2 to the power 5 minus r dot x to the power 2 times 5 is 10 minus 2 times what? 2r dot 5 to the power r dot x to the power r. Are we there? Expand this, 2 times 5 is 10 minus 2 times r is 2r. So from here now I'll still apply indices here, right? Look up. I'll still apply indices here. So if I have tr plus 1, that will be equal to 5 combination r, 5 combination r, right? So drop this down, dot 2 to the power 5 minus r, dot, this is x and x. So bring this one secondly, 5r, dot, combine these two, x to the power 10 minus 2r plus r. Indices, if I combine these two, because a plus, combine this plus this, I have this. So I have t to the power r plus 1 is equal to, from here now, from here now, I can just try to get r instead of wasting time. So for me, if I even proceed with this, I can see this x, let's apply everything here, and the value I'm giving x here to be equal to 7 here. So the task now is that I'll just pick out, I have x to the power 10 minus 2r plus r, that's what? Minus r. So it's equal to x to the power 7 as given from this part here, from this place here. So from here now, what do I get? So this one we cancel this, that becomes 10 minus r equal to what? 7. Let's get r here. From here, what's r? Please first follow the pattern of solving, right? So from here I'll have that. So from here, if this 10 comes, I'll have minus r equal to what? 7 minus 10 minus r equal to what? Minus 3 minus minus r equal to 3. So my r there is 3. So I'll go back here now and put r. So I'll get what I get. So I'll have t. So r9 is 3. That becomes 3 plus 1 equal to r9 5 combination 3 dot 2 to the power 5 minus 3 dot, observe is 5 minus 3, right? Dot 5 to the power r, 5 to the power 3 dot x to the power 10 minus 2 into 3, right? Plus 3. So I'm here. So it means that the fourth term, so what I'm asked to find there is the fourth term, right? So I'm saying the fourth term here equal to 5 combination 3. 5 combination 3 there. I have 10, right? Dot 2 to the power 2 dot 5 to the power 3 dot x to the power 10 minus 6 plus 3. This gives t to the power 4. Sorry, t4 is equal to what? 10 dot 4 dot 125 dot x to the power, if I 5 to the power 3, that's 125 dot 10 minus 6 is 4. 4 plus 3 is 7. So if I combine 10, 4 and this, I'll have t to the power 4 equal to 10 times 4 times 120, 125. 10 times 4 times 125. I have 5,000 x to the power 7. So when it says that, find the what? Coefficient of x to the power 7. You say coefficient is what? Number in front of that. So my coefficient here, the coefficient of x to the power 7 is what there? 5,000. Becomes my answer after solving this particular problem. So see you in the next class. We have come to the end of the study of binomial theorem. So see you in another new mathematics topic. So see you in the next class. Bye. Do well to join do well to follow us in our TikTok page, Facebook page and Instagram page. I'll drop the link to those page in the description of this video. So do well to share our videos to your friends, classmates, families so they can learn too. Goodbye. See you once again in the next class.